everyone, welcome to this comprehensive tutorial on trigonometry. In this video, we will explore essential concept that forms the foundation of trigonometry, including trigonometric functions and identities. We'll dive into the law of sines and the law of cosines, two powerful tools for solving triangles, as well as Heron's formula for calculating the area of a triangle when you know all three side lengths. Whether you're a student looking to strengthen your understanding or someone seeking to refresh your knowledge, this tutorial will provide clear explanation and examples to help you master these important topics. Let's get started. First up, let's talk about trigonometric function. Let's define our triangle. In a right triangle, we have three sides: hypotenuse, adjacent, and opposite. Hypotenuse is the longest side opposite the right triangle. Adjacent is the side next to the angle we're interested in. Lastly, opposite is the side opposite the angle we're interested in. Now, let's break down Sakatawa, a mnemonic device used in trigonometry to remember the relationships between the angles and sides of a right triangle. Sa is defined as sine is equals to opposite over hypotenuse. Ka stands for cosine is equals to adjacent over hypotenuse. Third is tuwa, which means tangent is equals to opposite over adjacent. Next, let's look at the reciprocal function derived from these ratios. Cotangent is the reciprocal of tangent. Cotangent is equals to adjacent over opposite. Second on the other side is the reciprocal of cosine. Second is equal to hypotenuse over adjacent. Lastly, the cosecant, which is the reciprocal of sine. Cosecant is equals to hypotenuse over opposite. To begin, let's visualize a right triangle where one of the angle is 30 degrees. In this triangle, we have the following measurements. Opposite side is 6. Hypotenuse is 8. To find the length of the adjacent side, we can use the Pythagorean theorem, which states a squared plus b squared is equals to c squared, where a is equals to adjacent side, b is equals to opposite side, and c is equals to the hypotenuse. The first step is to substitute the values. We have a squared plus 6 squared equals 8 squared. This simplifies to a squared plus 36 equals 64. Next, we need to solve for a. We will transpose 36 to isolate a squared. It becomes a squared equals 64 minus 36 equals 28. Now, we take the square root to eliminate the squared term. So the result is a equals the square root of 28, since 28 is not a perfect square. Now that we have all sides of our triangle, we can now find our sixth trigonometric function. Sine is equals to 6 over 8, and it is divisible by 2, so it becomes 3 over 4. Cosine is equals to square root of 28 over 8. Tangent is equals 6 over square root of 28. And square root is not allowed in the denominator, so we must rationalize it. And it becomes 6 square root of 28 over 28. Cosecant is equals 4 over 3. Cotangent is equals to square root of 28 over 6. And lastly, secant is equals to 8 over square root of 28. And same process, we rationalize it. And it becomes 8 square root of 28 over 28. And that's how we find our sixth trigonometric function. Now let's proceed to trigonometric identities. We have reciprocal, ratio, Pythagorean, and odd-even identities. Now, let's have an example. Verify sine x, tangent x, plus cosine x equals secant x. It's a bit confusing, but let's not get panic. The easiest thing that we can always do first is express individual trig function as something else. That means we rewrite tangent x as sine x over cosine x and secant x as 1 over cosine x. Now, the sine x terms multiplied to get sine squared x. Next, we multiply cosine x by cosine x over cosine x. So it becomes cosine squared x over cosine x. That may seem arbitrary, but we do this so that we can combine the fractions, giving us sine squared x plus cosine squared x over cosine x. The reason this is used for is that we can now use another identity we know, the one that says sine squared x plus cosine squared x equals 1. That means we can change this to 1, and we have 1 over cosine, and we did verify the sine x plus cosine x is really indeed equal to secant x. And for our third topic is the law of sine, which relates the lengths of the sides of a triangle to the sides of its opposite angles. It is expressed as a over sine A equals b over sine B and c over sine C, where a, b, and c are the lengths of the sides opposite angles a, b, and c respectively. For example, we are given the following information. Angle A is equals to 30 degree, angle B is equals to 60 degree, and side A is equals to 10. From this information, we can find angle C using the fact that the sum of angles in a triangle is always 180 degrees. So, 30 degree plus 60 degree equals 90 degree. 180 degree minus 90 degree is equals to 90 degree. So, RC is equals to 90 degree. Now, we know that angle C is a right angle, which means triangle ABC is a right triangle. Next, we'll use the law of sine to find the lengths of sides B and C. We can set up our equation to find side B as 10 over sine 30 degree equals B over sine 60 degree. Then cross multiply, so it becomes b sine 30 degrees equals 10 sine 60 degrees, and divide both sides by sine 30 degrees to eliminate it, leaving only b on the other side, which gives us a result of b equals 17.32. And for our side C, still same process. We need to set up our equation, then cross multiply, divide both sides by sine 30 degrees to eliminate it, leaving C only on the other side, and which gives us C is equals to 30. And for the law of cosine, which is used to find side or angles in any triangles, especially when dealing with non-right triangles. So it has different kinds of formulas that we can use, and it can be rearranged. It depends on the formula you need to use, or depends on the equation that you need to find. To visualize it, let's have an example. In a triangle ABC, A equals 24 centimeters, B equals 10 centimeters, and C equals 60 degree. The first thing that we need to find, or that we wanted to find, is the side C. In order to solve for this, we will be able to use the formula of cosine, which is c squared equals a squared plus b squared minus 2ab cosine c. To calculate for the side C, we do substituting the known values. It becomes c squared equals 24 squared plus 10 squared minus 2 times 24 times 10 times cosine 60 degree. To eliminate the squared, we use square root. So the square root of c squared equals c, and the square root of 24 squared plus 10 squared minus 2 times 24 times 10 times cosine 60 degrees is equal 20.9 centimeter. Next is to calculate angle B with the formula of cosine B equals a squared plus c squared minus b squared all over 2ac. Same process. The first thing is to substitute the known values. It becomes cosine B equals 24 squared plus 20.9 squared minus 10 squared all over 2 times 24 times 21. Then in the calculator, must click the shift sign, then the cosine. So it becomes cosine raised to negative 1, 24 squared plus 20.9 squared minus 10 squared all over 2 times 24 times 21. So it gives us an angle B of 24.51 degree. And for our angle A, we just need to add angle B and C, then subtract it to 180 degrees, which gives us 95.49 degree. And finally, for our last topic, Heron's formula, which provides a way to calculate the area of a triangle when the lengths of the three sides are known. The formula is K equals square root of S times S minus A times S minus B times S minus C, where S is the semi-perimeter given by S equals A plus B plus C all over 2. And to illustrate it, we have an example. A triangle with sides A equals 30, B equals 25, and C equals 9. Before we proceed, let us first calculate the semi-perimeter. S is equals to 30 plus 25 plus 9 equals 64. Divide 2, so it becomes 32. And for K equals square root of 32 times 32 minus 30 times 32 minus 25 times 32 minus 9. All over, it gives us K equals 101.51. Thank you for joining me in this exploration of trigonometric functions, identities, and K formulas like the law of sine, the law of cosine, and Heron's formula. I hope you found this tutorial informative and helpful in enhancing your understanding of trigonometry. If you have any question or would like to see more examples, feel free to leave a comment below. Don't forget to like this video and subscribe for more math tutorials. Keep practicing and remember that mastering this concept will greatly benefit you in your mathematical journey. See you next time!